Okay, Unit 5 is thermoplastics, and there are 4 parts. I try to break it into smaller parts so you can handle it. So we are now in the age of plastics because production of plastics is far more greater than production of steel, and we use plastic in many applications. So plastic actually it comes from chemical industry, and we synthesize them. Okay, so it's not plastic is not something that comes from the nature. We make it, and we make it in the lab. So here are the raw materials of plastics, and they come in pellets of flakes, powder, or granules. Okay, these are all synthesized chemicals, and we call them a special name, synthetic polymers, because they have molecular structure like a really, really long chains, and some of them are cross-linked. So for industrial applications, we use 2 main types of plastics, and we call them thermoplastics and thermosets, or thermosetting plastics. I call them thermosets. So Unit 5, Part 1 and 2, we're going to concentrate and study thermoplastics. Part 3 and 4, we're going to get into thermosets. So in thermoplastic, we're going to take a look at polymerization. They're just a plastic structure and the process that we use to chain the monomers together. Okay? And properties, and we're going to concentrate on applications. We're not in the chemical engineering technology, so we're not getting into chemistry, okay? Not the structural part, not in details. Even though we touch the properties, we're just going to go into general, alright, properties. And for our major, we will stress on the applications, yeah, and the properties that matter for making the product, alright? So thermoplastics they're just synthetic polymer. We make them in the lab, and they can soften when you heat them. Okay, so they're not very heat tolerated polymers. Of course, some of them can be able to tolerate heat to a certain temperature, but most of the plastic they can't tolerate heat, and they regain their solid form when cooled. It's meaning like if you cool it down, it's going to get back to the solid form. And that process, heating and cooling down, and take shape back, that can happen many times. So you can ground them up, and then you can reuse them after heating up. Okay, this is just a thermal processing, I mean heat, and then cool it down, heat, and then cool it down. For thermosets, they can pass through only one heat cycle because heating causes them to curing or setting reaction, meaning like they can go back to the original shape. So you can't remelt or you can reform thermosets by thermal process. Okay, it can go through only one heat cycle and change a permanent shape. It won't go back to the original form. So plastics are synthetic polymers, and you have to know what polymer means. Polymer is just a molecular structure. Molecule means like it is composed of a number of atoms, okay? Different atoms sometimes same atoms. So it depends on what molecule you're dealing with. Poly, if you think about the meaning, poly is many, mer is unit, mer means a monomer, okay? So polymer means we're connecting so many monomers in particular bonds. So polymer, many repeating monomer units. So you take a look at the example, and here I have ethylene. Yeah, ethylene, it has like 2 carbons, right, and 4 hydrogens. And this is a molecule because it is composed on 2 different atoms, right, in certain numbers. And this is polyethylene. So the monomer ethylene, they're all wound up in chains, very, very long chains. So polyethylene has many hundreds of repeating ethylene, and this is your monomer units, okay? And we call that polymer. We commonly call it polymer chain, okay? So polyethylene, in common word, we call them as a milk container plastic. So when you go to supermarket and you're gonna buy a milk container, right, a gallon or 2 gallons, not the paper carton, right, the plastic bottle ones. So these container plastics are made from polyethylene. So when you take a look at the ethylene monomer, you can see 2 carbon atoms and 4 hydrogen atoms, and you have double bond between 2 carbon atoms, and you have a single bond between hydrogen and carbon. So the bond in polyethylene, you're going to have ethylene molecules, they're bonded together in hundreds, and you're going to see a really long chain in polymer, okay? So making polymer from monomers by forming a very long chain, and we call that molecular chain, and that process is called polymerization. So we use polymerization to make monomers, hundreds of monomers, into polymer molecular chain. So what is this process? So this process is just linking the monomers together. So when the monomers are linked together, they form a very long chain. And this process, polymerization, it produces plastic polymers. And the polymers, their properties are different from that of the corresponding monomer. When you look at the polymer molecular chain, you can see 3 basic configurations. We have linear, and we have branched, and we have network. So linear configuration, see how it goes linearly. The main chain has no branches. For branch configuration, you can see the main chain, see here the branches. So the main chain branches out. For network, see these branches right there, they grow and then they connect right to each other. So you can see like a mesh right here, like a network. They can also exist as a hybrid, right, of the 3 forms. And the property of polymer is very dependent on the physical, these configurations of the molecules. So the property this plastic, alright, might have, it's not the same as the property this plastic might have, okay? Why? Because they have different configuration. This is a linear plastic, and that one is a network plastic. Yeah? That's why you can see the variation in plastics material outside with our naked eyes. So here we can see polymerization of these monomers making these polymers. So here you have ethylene, you have polyethylene, you have propylene, and you have poly, just add poly right in front of it, propylene, okay? So this is just abbreviation that they use in the plastic world. So you have PE, PP, PVC, PS. It's easier, right, for operators and managers to describe the polymer instead of saying the whole chemical terms, and they can't do it either. So you just have to go with PE or PP or PVC or PS. So we have vinyl chloride, that's a polyvinyl chloride, your famous PVC pipes, yeah? And your styrene, you have a polystyrene, yeah, PS. So when you take the thermoplastic processing, you have to process your raw material into some shapes, right? So this is a general process to process the raw plastic synthetic materials, your granules and your powders and your flakes. First, you're going to melt that raw plastic material, and then we're going to force it into the mold cavity. The mold cavity, this cavity, okay, is called die. This is just an industrial term. And then we're going to cool it down to harden it. The thermoplastic, you can cool it down to make shapes, okay, not like thermosets. So here are different molding methods that we use, or processing methods, in other words. Commonly, they just like a molding types of methods. Extrusion, we have injection blow and rotation for thermoplastic, okay? When you take a look at the extrusion molding, this is a highly efficient method. So the companies, they like to use it. So that process makes product by forcing raw material through an orifice here, or die, okay? We call this little orifice, a cavity, we call the die industrial term. So thermoplastic, we're gonna feed it through this hopper, like a little funnel right there. Melt and force it, okay? So this screw is to add the pressure, okay, for that material incoming material into this press. And we're going to use that screw to increase the pressure and force it, all right, in that chamber through this cavity or the die, okay? Now the product is going to come out of here. So what can we make? So we make some products like pipe, tubing, wire coating, plastic film, sheets, paper coating, foil coating, filaments, yarn tapes, plastic tapes. Okay, this is not all, that's just a few examples, right? So this is your extrusion molding instrument. So here are some examples of your extruded products. This is from the textbook, that's from the internet. So you can get like cups and buckets and things like that as well. Okay, not in this, so this only shows some pipes here. Not in this picture. You can Google it and it will come out. Another one is injection molding. This is a major processing technique. And with this process, we make a lot of thermoplastic products. So what do we make? We make shaped sides. And these shaped sides of the products depend on the mold cavity right here, okay? Again, our industrial term is a die or die head. So hopper is your feeder. We're going to put the raw material through this feeder. And here is we use many different screw type, okay? So during this process, solid thermoplastic particles is going to come through this hopper, and this is totally the extrusion chamber, or we call the extruder barrel, is completely heated. Okay, you have to heat in order to mold your plastic. So the molten material is going to transport it into the mold with this screw, rotating screw. It's going to move them. And then there's a plunger, you can see it here, and that's also going to add some action on that melted or heated molten material. And it's going to come out of this die head, okay? And we make shapes and sizes depending on that cavity. And we call this mold cavity or die head or die. The next method is a container molding, common word. Technical term, blow molding. So this is your blow molding instrument. It's a major method to make hollow containers like that, okay? So this method uses compressed air to inflate that molten plastic inside, okay, coming in from your hopper to conform to the mold cavity here. So this is your air, okay, route. And you can see here there's a label. And here, that's your bottle that you just molded. And we have to, because this is heated in the extrusion chamber, you have to cool it down, okay, by using water. So water cooled mold in the example. So first you're going to melt the thermoplastic resin. Thermoplastic resin, this is just a raw material, okay? Melt it, and then you're going to form a resin by extrusion. And then blow that resin into the desired shape, okay? So the products we make by using the container molding, of course we'll make containers, yeah? Containers with or without handle or spouts, bleach bottles that you use at home, liquid soap dispensers, car gas tanks, and the Fermi fertilizer water container, the giant, right? 100 gallons or 200 gallons, these containers that you can see when you go out into the country. Okay, now let's take a look at the die. Okay, head right here, but this one you can see the mold cavity very clearly, and this is the first half and the second half. Parasin is nothing but just a cylindrical tube. Okay, it's going to come down, and the mold cavity is going to close, and you're going to blow it, yeah, to make the shape. We use air to blow it, so it gets inflated, and then we use water to cool it down. So once it's done, we open the molds, and you get the container made of plastics. Here in this case, thermoplastics. Again, bring the parasin down, close the mold, blow with the air. Your heated molten plastic is going to come into here, and you blow with the air, yeah, to make the shape. It got inflated, and then cool it down. We're using water, and then open it. Pretty easy, yeah? You don't have to do it by hand. They're all automated, okay? They're just big equipment in the factory. Okay, the next one is a rotational molding. Since it's rotational, we use another word for centrifugal casting. So we can make irregular hollow products with this method. Don't forget the keyword, irregular hollow products. And it uses high and low density ethylene in low pressure rotating mold cavity, okay, to make the products. And here is a two-dimensional cross-section that you can see how it can be rotated. You have your heat chamber, you have your air blower right here, and the water spray to cool it down. Yeah. Okay, then we will classify all thermoplastics. So there are many different types, but here we're going to concentrate on 2, 3, 4 of them because they're important and they're commonly used. So the very first one is polyolefins. Second one is your styrenic plastics, vinyl plastics, and your acrylics. Okay. Now we go this way. So polyolefin, styrenic plastics, vinyl plastics, and your acrylics. Alright, the first class is your polyolefins. They're low cost, so cheap, and we have 1, 2, 3, 4, 5 important polyolefins that we commonly use in industries. So one is your PE, that's your polyethylene, your PP, your polypropylene, your PB, your polybutylene, and then your PMP is your polymethylpentene, and then your EVOH is your ethylene. This is phenol, and that's alcohol OH, okay? Okay, the next class is styrenic plastics. It's just a family of polymers related to styrene, and you can picture styrene as a foam. So polystyrene PS, styrene acrylonitrile is your SAN, S-A-N, and your ABS plastics for your wire coatings, okay? The next one is your vinyl plastics. So polymers related to vinyl chloride. Your polyvinyl chloride, your PVC pipes. Your polyvinylidene chloride, PVDC, okay? We use them from the medical reps to keep the medicines stay a long time, okay? Polyvinyl chloride, your PVC, is one of the widely used plastics. And this is it's it's going hundreds and hundreds of times with this monomer. That's the polyvinyl chloride. And there's a one chloride here. It just add a chlorine to your ethylene, yeah, and then chain it for a long molecular chain. So they come in rigid. Also, they come in flexible grades. Okay, two different PVC. So polymer should not be overheated. This polymer, you can't heat it because it's going to degrade very easily. So that degradation of PVC is corrosive, right? Because of that chlorine. So machinery surfaces in contact with the polymer should be corrosion resistant. So therefore your processing temperature should be limited, okay, to as low as possible. Because if you overheat, the chlorine is going to mess up with the corrosion in the machinery. Okay, machinery mean like making products, but using these big giant machines. We don't want to mess up with the machines, so therefore you can't overheat your PVC, okay, when you are processing it, because it's going to damage the system. So you have to be so careful about it. Yeah. Again, temperature control is so important here when you're dealing with PVC production. or some products, using PVC. This is just a plastic anyway. Or you're gonna dispose PVC. So flexible PVC, they have plasticizer to soften the plastic. For rigid PVC, they have PVC resin. That's a heat stabilizer, and also an impact modifier. Okay. You can use it with ABS or chlorinated polyethylene. Because that PVC resin, this guy, okay, in the rigid PVC, it can ignite and it will ignite. Even if it is self-extinguishing. So when PVC resin is burned, you will have hydrochloric acid because it has a chlorine in it, okay, and can form hydrochloric acid and all the toxic corrosive chemicals, alright, is going to mess up. So when we dispose, alright, polyvinyl chloride in the landfill, you have to be so careful because you can burn, right? Because it will ignite because of this PVC resin in the rigid PVC plastic products, even though you throw them away. Okay, in the landfill, you have to sort them out very carefully and use a special incinerator like that to dispose of PVC. Okay. Okay, so the last one is acrylics. So acrylic is a polymethyl methacrylate, PMMA, and is commonly known by its trade name plexiglass. Okay, we always say plexiglass restaurant, they use it, right, in COVID period to ward off the virus direction. And plexiglass is hard. Okay, acrylics, they're hard, rigid, and very much transparent. That's why we use it as divider between the police, right, and the criminals in the back of the police car. That's not glass. That's just plexiglass, right? Really hard acrylics. The taxi driver also use it, especially big cities like New York, California, Japan, Tokyo, right? They use also in China also, where they use a lot of cars with plexiglass, right, between the driver and the passengers. Hospital, they use plexiglass, right? So here, when you take a look at the process, we have methyl acrylic acid, and we're going to apply alcohol to it, and you're going to get polymer, PMMA, which is your polymethyl methacrylate, okay? And here is your monomer. They actually need to put in right here, but that's okay. It depends on some people put right here and some people put right there. It means that it's a long chain of the monomer, okay? This is just a single molecule. Polymer PMMA, there are so many PMMA in a very, very long molecular chain. So what do we do with this? We make low-cost lenses, windows, and safety glasses. Yeah. Okay, that's it for part 1.